Okay, on your notes, the next part says solve using square roots. So we talked about we're solving quadratic equations by factoring, by taking square roots, by completing the square. Then another time we'll do the quadratic formula. In order to solve using square roots, we got to review a little bit. What do we know? Is it good? Square root of 36. You will look at that and tell me 6,
Plus or
right?
minus 6.
But yeah, if you take the square root of both sides, there are really 2 square roots of 36. Because negative 6 times negative 6 also gives you 36. So for now, we're going to write both possibilities, plus or minus 6. What about the square root of negative 8? That's square root of negative 1 times square root of positive 8. It's going to have an I in it. It'll be a plus or minus I plus square root of 8.
2 square root of 2.
It's I times 2 square roots of 2, but we will write this as plus or minus 2I times the square root of 2. Oops. The square root of x squared. Yeah, plus or minus x. On this one, if we think about this, this means x plus 4 times x plus 4 inside. So we got 2 of them, we got a pair inside, we can take one out. But if I consider plus or minus, if I consider 2 possible options, plus or minus all of this, the positive version is just x plus 4. But what about the negative version? Negative x minus 4. The same is true on this one. It's plus or minus 3x minus 5. If I consider the positive version, it's just 3x minus 5. It's exactly as is. If I consider the negative version, negative 3x plus 5. So, if you can get something squared by itself, like these 3 examples up here, notice how all 3 of these have something squared all isolated. If you can get something squared and isolated, then the easiest thing to do to solve them is take a square root of both sides. You could do it the hard way. You could expand this out, x plus 4 times x plus 4, which would give you x squared plus 8x squared, 8x plus 16, and then subtract 36 and make it equal 0, and then factor. You could do that, but we don't really want to work hard, we want to work smart, and that means, in this case, the shortcut is just take the square root of both sides. The square root of x plus 4 squared and the square root of 36. Anytime you take the square root of both sides as a process of solving the equation, you must write plus or minus. Not on both sides, because if you write plus or minus on both sides, it'll kind of take you around in a circle and you'll find the same 2 solutions twice. So you don't have to do it only on one side. Square root of x plus 4 squared is just x plus 4. Square root of 36, plus or minus 6. So if I subtract 4 from both sides, then x is, start here, negative 4 plus or minus 6. So, don't leave this. Those are like terms. Combine them. That means x is negative 4 plus 6, or 2. But also, the other possibility, x equals negative 4 minus 6, or negative 10. Let's think about these for a minute. What if I plug 2 in the original equation? 2 plus 4 is 6. 6 squared. Yep, that gives me 36. What if I plug negative 10 in the original equation? Negative 10 plus 4, that's negative 6. Negative 6 squared, negative 6 times negative 6, also gives me 36. So both of those are solutions to the quadratic equation. Example 2. We have another one where we have a square isolated. So anytime we have that, we can just take the square root of both sides. The square root of 2x plus 3 squared is just 2x plus 3. The square root of 24 is plus or minus, can we do better than the square root of 24? Yeah, because it's 4 times 6. So plus or minus 2 square roots of 6. Now what? If we subtract 3 from both sides, then 2x equals, start here, negative 3 plus or minus 2 square roots of 6. And finally, if we divide both sides by 2, x equals -3 plus or minus 2 square roots of 6 all over 2. True or false? It's okay if I cancel those 2's. Not okay. The only thing you could do is split this and make it in 2 separate fractions, and then you would be able to reduce one of the fractions. This is probably the most common way you'll see the answer on these. And here's what you need to know. This just means some number. It is irrational. It's also real. There's not an I in it, so it's not an imaginary number. If you graph that number, it would really show up on the x-axis. But it would be a decimal value because there's no way to get rid of the square root of 6. You can even check this. If you want to check it, you can tell your calculator to do -3 plus 2 times the square root of, it will open a parentheses, you got to close it. Tell your calculator to do all of the top, then divide it by 2, get an answer, and store it as x. Then, if you go back and retype parentheses 2x plus 3 squared, it better give you 24. And it will, because this is the correct solution. Example 3. On this one, if you take the square root of both sides, then you notice that we're taking the square root of a negative number. So what kind of a solution are we going to get here? Yeah. We have just 4x minus 5 equals plus or minus. We've done square root of -8. It's square root of -1 times square root of +8, or I times 2 square roots of 2. But don't write I2, write plus or minus first, 2I times the square root of 2. Then solve for x, so undo subtraction, add 5 to both sides. 4x equals, start here, 5 plus or minus 2I square roots of 2. Then to finish, divide everything by 4. So x equals this. I can't cancel 2 over 4. Those are terms. Can't reduce. The only thing I could reduce if I split it apart and made it 2 separate fractions. But as long as I have it all written as one fraction, I can't reduce. This solution, because it has an I in it, is complex. If you graphed it, it wouldn't show up on the x-axis because complex numbers are not real. They don't really show up. Then, there's a next section on your notes that says, solving quadratic equations using factoring and square roots. Remember how to factor this. X squared plus 12x plus 36. Is it a perfect square trinomial? X times x, 6 times 6. 6x and 6x doubles to be 12x. So remember it factors as x plus 6 squared. Here's another one. If you see 4x squared minus 20x plus 25.
2x minus 5 squared.
Good. This is 2x times 2x. This one is 5 times 5. So 2x minus 5 squared. It is a perfect square trinomial. Down at the bottom, you have instructions that say, solve by factoring and then taking the square root. These are kind of creative ways to solve a quadratic equation. It's kind of a thinking outside the box method. If you see x squared plus 12x plus 36 equals 81, a lot of you would probably say, I will make that equal 0 and then factor, and that would be fine, that would work. But if you're kind of really on your toes and thinking outside the box, You might look at this and say, hey, I recognize this. This thing is a perfect square trinomial. And it factors, we just did it, as x plus 6 squared. So then we said, anytime you can get something squared by itself, you want to take the square root of both sides. So the square root of x plus 6 squared is just x plus 6. Anytime you take the square root of both sides, you must remember plus or minus on one side. There is a square root of 81. It's 9. So x plus 6 equals plus or minus 9. If I subtract 6 from both sides, then x equals, start here, negative 6 plus or minus 9. These are like terms, so don't leave it like that. Negative 6 plus 9, negative 6 minus 9 means that 3 is a solution and negative 15 is a solution. If you plug 3 into this equation, it'll give you 81. If you plug negative 15 into this equation, it'll give you 81. You found 2 solutions. Look at the next one. On example 2, you have 4x squared minus 20x plus 25 equals negative 8. If you're really thinking on your toes, what you might do is say, oh, I'm going to make that equal 0 and add 8 to both sides and then try to factor it. And you can do that. It'll be harder in this case. If you're really on your toes and you recognize what we just factored a minute ago, you will know that that is a perfect square trinomial. And it factors as 2x minus 5 squared. Anytime you have something squared all by itself on one side, you can take the square root of both sides. But this time, what kind of a solution is it going to be when we have the square root of negative 8?
Imaginary.
It's going to be imaginary complex. So 2x minus 5 equals plus or minus. We've done this one a bunch. What did we get for the square root of negative 8? 2i square root of 2. Then add 5 to both sides. 5's are gone. 2x equals, start here, 5 plus or minus 2i square root of 2. Then divide everything by 2. True or false? I can cancel those 2's. Okay. Y'all go that way. I'm going to do one more problem before we turn that camera off. So, if you're here for lunch, you're sticking around to do this one up here. On this one, perfect square trinomial. So it factors. This one's 3x times 3x. This one's 1 times 1. It'll factor to be 3x minus 1 squared equals 45. So then, if we take the square root of both sides, don't forget plus or minus. I forgot plus or minus on this one. 3x minus 1 equals plus or minus 3 squared. And then add 1. So 3x, start here, is 1 plus or minus 3 square roots of 5. And if we divide both sides by 3, can't cancel those 3's because they're terms. There's where we land. So the solution to this equation is irrational. 1 plus or minus 3 square roots of 5 all over 3. You plug in that ugly value for x, it makes this equation equal 45. I shouldn't You shouldn't be mean to call that an ugly value, it's just irrational. Patrick, will you turn that off, please?